Okay, for the general Q&A, we have Darryl is here. Mike Orshon, who's the manager of the program manager for the DDK, who can answer a lot of non-file system specific questions about the DK, is also here waving his arm, the furry guy in the back. And we can defer questions to him. Mary Hutton wrote most of the documentation for the DDK. Well, the good parts of the documentation for the DDK is here as well. She can answer some questions. Let's take a little bit, while you formulate your questions for all these people, let's take a couple of minutes on administrative things. Darryl started his talk on Tuesday by asking how many of you were working on file systems of what particular sort. I think it will be informative. You probably all still raise your hands the same way, but maybe maybe we persuaded some of you or convinced some of you or something. How many people are still intending to write a mass store file system for Windows NT? Okay. I don't see quite as enthusiastic a raising of hands as I did on Tuesday morning. I'm encouraged that you've stayed the course. Okay. How about some kind of hierarchical storage manager or something along those lines? Ooh, okay, that's a big biz. All right. How about a distributed file system? Okay. People, that's good. I like to see it. Any kind of filters, anything of the sort? All right. You see a lot of people that want to do filters. Okay. What's the other one? Network redirectors. Well, redirectors, distributed file systems, same sort of thing. So, I'm sorry. Yeah. Everybody who hasn't raised their hand, raise your hand now. Okay. Well, I'm glad to see we haven't completely turned you off. I'll be honest in saying that we decided during the course of this that weren't going to really pull any punches. We've gone the course from Darryl and his extremely good high-level reviews and the way this stuff is supposed to work, down to David, who tells us the way it actually does work and goes into pretty gory detail about it. We've gone from showing you the pretty face of Windows NT all the way to, you're seeing whatever work may actually exist in pretty glorious Technicolor. And as David says, you'll have the movie to run over and over again. The videotapes from this will be minimally edited, and minimally means that I consider the Q&A sessions to be at least as important as the presentations. And unless the video guys stop me completely, I'll say that the Q&A sessions are going to be in the videotapes as well. They will be turned around to you as quickly as possible. Jamie Hanrahan, who runs Kernel Node Systems, has agreed to set up an internet list, a mailing list for file system related information. That will be NTFSD, and I'll have a slide for this, and I'll actually send out a mailing follow-up for the conference to everyone who attended. NTFSD@cmkrnl.com. NTFSD@changemotekernel.com for us old BMS hackers. cmkrnl.com. That's an instruction in BMS, or in Baxis. I'm sorry? You're allowed to say BMS. I can say BMS all day long. It's not my operating system. A slight personal diversion. I worked for DEC for a long time supporting DECnet and BMS, so I think I'm allowed to say it. Hold my head up with pride as a person who worked on a leading edge operating system 10 years ago. That's a standard list server. If you want to join, you'll send mail to ntfsd-request@cmkrnl.com with a piece of mail that has as body the word subscribe, space, your email, space, your full name. Pretty standard list server. If any of you have used these before, it'll be there. And it has the standard help and all the rest of the stuff. Sorry? the question is, am I going to have a slide for this? I'll mail to everyone I'll put a slide up tomorrow with it, but I'll also follow the conference up with a piece of mail, not electronic, but paper mail that has all this stuff on it. Because there's a lot of things I promised you that haven't gelled yet. Jamie came up and talked to me about this, I don't know, maybe 2 hours ago, 3 hours ago, something like that. How many of you are intending to stay until tomorrow? Okay, most all of you. All right. This pretty much concludes the portion of the talk that is specific to file systems that are local to one machine. Tomorrow we talk about networking stuff almost exclusively. So, if you're not interested in networks, you can go away if you feel like it, but we encourage you to stay and what the heck, maybe learn something. Let's go ahead and do the general Q&A. If you queue up at the microphone so we can have your questions recorded for all time and space. And everybody who's going to answer questions can sort of migrate up here and we'll ask away. This is your opportunity. If you have questions about the way the internals of NT work, if you have questions about precisely what the code does in one form or another, we actually have code up here that we can refer to and give you exact details if we need to. So, go ahead. Those questions.
I'll get the video.
Okay, just a couple of them. Could somebody go over, I know that when we were talking about mount yesterday, that it essentially said that the file system drivers will be called and asked whether they recognize the volume, whether they're going to claim it. How does that happen when an open happens? If an application wants to open, X : whatever, who's going to do the parsing on that? Or does every file system get called in turn when something's going to be opened with the full spec name to determine if it's theirs or not?
Okay, well, first of all, it depends on what X : refers to. Mm-hmm. X : refers to an external drive, i.e. a network redirected drive. And X : in the Win32 subsystem is going to get translated in a /device /mup /X : whatever you said.
Yeah, if it's a local file system.
If it's a local file system, then it's going to get, D:, let's say D:, is going to get translated into /DOS devices /D:, whatever you said, which is, and /DOS devices /D:, is actually a symbolic link that points to a device object, such as /device /hard disk 0 /partition 1. That name up to that point is translated by the object manager. The object manager namespace begins with a \. We go along this name, traversing the path until we get to something that we recognize. /device /hard disk 0 /partition 1 is a device object, and it has a parse method. It's an object that has a method. The method that it calls is IOP parse device, right? Is the name of the routine internal to the I/O system. The I/O system then looks at this device object, which now has a pointer to because we found the name, and the object manager called me and said, okay, here's this thing, and here's the remainder of the name. The I/O system looks at that device object, looks to see whether or not there's a VPP pointer. If there's a VPP pointer, then it looks to see whether or not the volume's been mounted. If it hasn't, then it stops what it's doing and calls another internal routine to go mount the volume. What that routine does is it goes out and takes all the appropriate locks. There's a database lock in the I/O system it takes. There's another one on the device so that we can't try and mount the thing twice. It then goes and creates an I/O request packet that has enough stack locations for the first file system and the device drivers. And it calls it and says, please mount this thing. All of the file systems are located because the way they're located is when you call IO register file system with the device object that you created in your file system's initialization routine, I put that in a queue. Okay, so I simply walk down that thing and call each one of you in turn until someone says, I recognize this thing, and we mount it.
When you put that in the queue, is that where a letter is associated with it?
No, drive letters don't have anything to do with anything as far as the I/O system or any file system is concerned. They're just a symbolic link.
Okay, but you've got somewhere where the linkage is made between the drive letter and the DOS devices.
Yeah, that's that initialization time. we walk through all the devices in the system and we apply the same naming rules that DOS does. There's all these things. If the first device has multiple primary partitions, or first device doesn't have any primary partitions, the second one only has extended partitions, and I mean, it's really crazy, but that's how those things get.
Okay, so that's done before the file system ever even registers.
That's correct. File systems don't, with the possible exception of if we ever have to support that bag of dirt compression stuff that we've shipped in the past, and other things that we've called operating systems in the past.
What's your opinion, Darryl?
Just one other thing. I just want to confirm. No, IO Manager doesn't do any parsing beyond stripping off the C colon or D colon. It's not.
You don't get that. Once we've translated the name into /device/hard disk, let's say that the name of the file that you're trying to open was d:/foo/temp.bar. Okay? The D colon, by the time you get it, is gone. I've given you a pointer to your device object, i.e. the volume device object that represents your idea of what media is mounted on the device, represented by some drive letter which nobody cares about anymore. And the open, I'm going to tell you in the file object, the name you're going to get is /foo/temp.bar. So you're supposed to open that file relative to that particular device volume object.
Okay, but you don't make any assumptions about anything beyond there, because it may not be // it may be all kinds of strange stuff.
That's correct. It could be anything under the sun.
By the same token, open relative to the current working directory are always path relative to the root.
Okay, the question was, by the same token, does that mean that opens relative to a root directory that you have open as a current working directory or whatever?
No, current working directory, that's not root. Do I get?
Yeah, okay. I'm using the word root to mean the thing that you're currently going to. Okay, in this case, basically what's going on here is the object attributes that I'm passed to in the create file API say that what this name is a name that's a relative to a particular directory, and I'm handed a handle to the directory, and I'm handed a name. I call the object manager and I say, here's this handle to this directory, tell me what it is. What he does then is he goes off and figures out, oh, this is a pointer to a file object, and there's a method for parsing a file object. That happens to be IOP parse file. So he calls me back, and the IO system then takes what I'm passed, which is the file object, and calls IOP parse device with the device that the thing's open on and the name. So by the time you get it, what you see is you see a file object that has a related file object pointer in it. That is to say, this file is being opened relative to this other file, and the name you see is whatever name they passed in, and it's relative to that directory.
Okay, next out of the microphone.
I have a question about the user interface for editing ACLs on file systems. If I am trying to implement a file system that potentially has a slightly different set of permission bits from that is standardly seen on NT file systems, is there any way I can override the screen that is presented to the user in the ACL editing interface and present my own screen and process whatever the user answers to all the blanks in it?
That screen that you see in File Manager is a DLL. It's called ACL-edit.dll. You can replace that with whatever you want. I don't know, we were talking about publishing the interface to that. I don't know if that was done or not. I know that it's in the works, so I don't know where to tell you to find it. But the short answer to your question is yes, you can do whatever you do. I don't believe it's published now.
That's part of Jim's security thing.
Right. Can you change this as well as replace it? It's a private discussions up here. It sounds like that this might be part of what Jim Kelly is working on when he's speccing everything that is not yet spec. This will hopefully be included. I don't know, as I said, exactly where it's going to go. The short answer is yes, you can put up anything you want, and what we would give you is what the interface of this thing is. So as long as you provide something that supports a similar interface, you can pretty much make it look like whatever you want. A more interesting question is how much do you want to, how do you intend to change the bits that refer to file accesses?
For example, to use the set of bits that the DCE uses.
Okay, this gentleman,
I talked to Jim about this.
which is the NTFSD, okay?
I talked to Jim about this a couple hours ago.
Okay.
He suggested I talk to MCS for this particular item.
The interface.
Yes.
Okay, right, which basically means that...
I never heard that.
Right, the gentleman said that according to Jim Kelly, one can talk to MCS for this, which means that it's in a better, which means that it's available through them now and will then be in a more formal channel later. MCS is where things go before we actually put them on paper. Back to your question though, what exactly, one more time, what are you planning to do to change the access?
For example, in the DCE DFS, it uses a different set of bits from what the standard NTFS uses. They're just ever so slightly different, and it would be nice if the user would directly edit what is expected to be on the disk at the server, rather than having the user have to think, well, a DFS execute bit is going to be slightly different from an NT execute bit.
We just plan on choosing the name of the bits, not the semantics. Hey, if you change the semantics, for example, let's say that you move the read bit, right?
Okay.
If you move the read bit, the I/O system, when it calls the object manager, is going to say, I have a handle, I have a token for who this person is, and the desired access that they have to have, this particular handle, is this bit. If that bit isn't on, then that operation is going to fail with an access denied.
On the other hand, it's possible in a distributed file system, for example, that access check would be done at the server rather than at the local machine. So it might have a different pattern of bits that it's going to compare at the server. This access check might not be done by the local NT reference monitor.
Okay, that's fine. The client side, however, is still going to have to go through a handle translation in order to get to the server, and at that point we're going to ask what the desired access is, right? So that part still has to work.
Okay, so we're going to have to do some of the translation locally anyway.
Right. Something I might point out also is that the ACL architecture is extendable. We predefine certain types of ACEs, ACE being the access control entry that Jim Kelly talked about. If we are processing an ACL and we find an ACE type that we don't recognize, we're just going to skip over it. You can put whatever information you want in there that's meaningful to somebody else so you can drag it around. And we promise to ignore that forever. Just don't use a type that we recognize, because then we're going to expect it to make sense. So I don't know if that helps or not, but it's something you should be aware that you can do.
That sounds like it is quite helpful, actually. Thank you.
Hi, this is probably for Darryl. There's a committee or working group called DMIG that has proposed some kind of a standard for file migration hooks in the kernel. A standard API, system call level interface, just to provide very low-level mechanisms or hooks for file migration, and that the independent software vendors could layer their products on top of. And these hooks wouldn't include any policy or anything like that. That would be up to the ISV's products. And this has mostly been going on in the Unix arena. I was wondering if there's any plans for NT to include this DMIG standard or consider it.
Not that particular standard, but I've certainly thought a lot about, for all of the people in this room that are writing filter drivers, for example, what would it be like if I simply said that, gee, what I'd really like to do is just make your filter driver a simple little DLL, and anytime any openness to any file system, I'll run around and call all of you first. that'd make everyone's life a lot simpler. Another thing that would make everyone's life a lot simpler is if David sat down and wrote the generic file system, which then did call-outs that said, okay, here's some data, it needs to be written, go allocate the thing and write it at the lowest level. All those things are things that I'd like to do at some point. For me, it's a matter of time and resources. So yeah, I'd love to do something like that. I'd love to make everyone's life simpler. A number of people have come up to me and said, gee, how come I can't run my file system driver that I'm developing for Windows NT on Windows 95? I mean, why don't you guys get your act together and make everything the same? Well, the good news is that the IO architect for Chicago and I have been working on trying to figure out how to solve this problem. The bad news is there's like thousands and thousands and thousands of people who want to write device drivers like SCSIs and videos and network drivers, et cetera, et cetera. There's like, this is it for the file system guys. And the file system interfaces between the two operating systems are radically different. In fact, they're much worse than they are between device drivers. So we're working along trying to get to some point where if you wrote a single device driver, you could actually run it under those systems. We're not there for file systems, and I don't see us getting there for file systems. I think that in the future, we'll have more and more NT systems and less work. What we have today is workstations. NT will take over the workstation market, and then it won't be a problem. But well, I mean, when you think about it, okay, so everyone laughs. But ask yourself the question: what did a 386, a high-end 386 machine cost 4 or 5 years ago, versus what 486, 66 with 16 meg or 20 meg with a couple of 100 meg drive is going to cost in a couple of years from now. And then ask yourself the question, how much is it going to cost to just slap in another Pentium processor inside that machine? And oh, by the way, the workstation software that we're supporting today, if it is an NT, doesn't support that second processor, or the third, or the fourth. You have to solve that problem, right?
Thanks. If I could ask one more thing, do you have a Unix, or a SCSI pass-through driver? A lot of the Unix platforms have what they call a pass-through driver, where a user-level application can send SCSI packets down into the kernel.
Yeah, there's a device I/O control that exists that goes straight out to the mini port.
Okay, thanks.
Yeah, could one of you comment on removable media? Like, for example, if I'd want to make a Macintosh file system that works with a floppy disk. From what I've seen, it looks like a file system hooks itself up to a device or a disk driver at initialization time. There's no way to get it to dynamically change.
No, it's certainly possible today to take a floppy and make it different kinds of media. You can do that with Bernoulli's today. But basically, here's how it works. Is this thing on? Or I can only hear me. That's because I talk so loud, I guess. Someone goes to open the first file on a device that's never been mounted. When that happens, we go through the mount process, and now there's a device object that has a volume parameter block, and the volume parameter block points to the volume device object that the file system created. Okay, now those two guys are tied together. At some point in the future, hopefully the user's closed the handles to the files. He hasn't, we'll deal with that in a minute. Basically what happens is the user goes over and takes the floppy out of the drive. Okay? When they put the new floppy in the drive, there's a bit set in the device object at the hardware, in the device driver for the device object itself for the hardware that gets set that says we need to verify that this volume is the same thing it was in the last time. The next time an open comes to that particular device, what's going to happen is any request that gets sent down to the device driver is going to get rejected, and it's going to say we need to verify that this is the same volume. What's going to happen is the file system is going to go out and it's going to say, this is not the same guy. So what happens then is we go through the mount process all over again. Now another file system gets an opportunity to create a volume device object and mount the thing, and we get a different VTB, et cetera, et cetera. if there were any handles open to the original volume, what will happen is any I/O request that comes in for that, that file system will get it, and eventually what will end up happening is you'll get a pop-up that says, hey, you know, now we're trying to access the volume that was in there before, put it back, right? And we do that using the VPB.
Another quick comment. Just from seeing your example of it, that it took like over 8 months to fix one deadlock problem, I guess. Could you give any comments on what you think the resource requirements are just to test the file system, like from a manpower point of view?
We already know it takes a year, right?
No comment. No. I don't know. I think that there are a lot of operating systems that are very complicated. This one in the file system cache manager, memory manager interface is pretty complicated. It works really, really well when it works. Every once in a while it doesn't work, and you gotta go figure out why not. We do run, as David pointed out, several hundred machines every night, run stress to the point where the machines almost fall over on themselves. And we do that every night before we ship for months. And we run against servers. We do thousands of connections to servers, and we bang away on those. So we're trying really hard to find all these problems. For device driver writers, we have a certification process that we go through to help find those kinds of problems. I don't know whether or not we have any plans to do that for file systems. Right. We have a hardware compatibility test team that lives upstairs from where we happen to live, and they have some stuff that apparently works really well for file systems.
As far as a formal set of tests, I've talked to several of you several times about this. It's something on the wish list, but there's no resources assigned to it. There's no time schedule assigned to it. So yeah, it'd be really cool to do it, but we don't have any formal plans to do it right now. I say, gee, it'd be really great. I think Darryl would agree with me, but he ain't signed up to do the work.
The other thing is, I would suggest to any of you that are actually going to write a file system, make sure you self-host yourself for a long time before you actually ship it. Right?
A long time.
My question is also related to the removable media question. The answer you gave suggested that the mount would sort of occur on demand, in the sense that the system would find out that the media had been changed until you actually tried to get to something. It seems like for performance reasons, and particularly in a higher performance, bigger device, you may want to respond immediately when the media is inserted, so you can save some time there. Any recommendations for how you go about doing that?
Oh. I guess my problem with your question is you mentioned high performance and you mentioned removable at the same time, and I don't see those two things as amenable. The melt process hardly takes any time at all. I mean, the melt process basically for our file systems today means go out to the home block or boot block or signature block or whatever. Oh yes, it's one of these things. Okay, create the data structures, and in our file systems, that means go out and create a VCB, a volume control block, a GCB for the directory control block for the root of the volume, and go in and figure out what's out there. It's not a very expensive operation.
Well, yeah, that part of it, but
the other thing is it is possible to have the user tell you to mount and dismount things explicitly.
well,
There's no user interface for that, but you could write one. I mean, it's just an FS control.
yeah, I'm actually talking about high performance in the sense of like 12-inch optical, where you have robotics for loading the media and so on, and high performance does apply really. For example, if you can save half a second on your mount time, it's really, really worth doing. And for example, if you've got to do let's say 5 or 6 or 10 reads of the optical media to actually create your directory structures or whatever structures you need internally, then that can slow things down quite a bit.
Agreed. Yeah, I don't know how to answer your question other than to say that we try really, really hard not to mount things because I don't want to load any file system drivers for anything that no one's touching. For example, if I have a floppy and that's the only fat media I have in my files in my system, why load the fat file system at all if the only thing that I'm ever going to touch is NTFS? So I try really hard not to go get that file system loaded into memory because it takes, I mean, they're all the code and all the data that's used for page fault paths have to be there, right? So that's a bunch of physical memory that we've locked down, you cannot use, the users cannot use, applications can't use, et cetera, et cetera. We can't use any of those resources for anything, so I try really hard not to. If you wanted to, there's no reason that you couldn't go out and ping the volumes and that will mount them. Or I mean, you could write an application that wakes up every couple seconds or minutes or whatever. Well, it would certainly be possible to have device drivers, you know, call the I/O system and say, "Hi there, someone just inserted something into me," or whatever. Floppies, for example, couldn't do that, however, because they don't interrupt. You don't know until you spin the motor back up the next time you go to use the thing. You know, that takes 500 milliseconds right there just to wait for the thing to get spun up. And you don't find out that the change line's ever even been set until that point, and there's no interrupt involved or anything.
Okay, that's helpful. Thanks.
Yeah, one quick one, getting back to the question earlier about partitions and associating drive letters, partitions and such. How do you determine what is a mountable partition? If this is happening in a NIT time, is there a table somewhere or some kind of configuration thing that we need to make sure that some partition code is going to be recognizable as potentially mountable and given a drive letter?
Yeah, there's currently, we use the same specification that's used for OS2. Basically, there's a specification for what a primary partition looks like, for what an extended partition looks like, and for what a logical partition within an extended partition looks like. We support primaries. We support 1, 3, 5, and 7. 1 and 3 are 2 different DOS types, and 7 is an installable file system. 5 is extended, and I think we may also support Unix.
Right, I've seen the list. How do we change that list if we have something that doesn't use one of those? I mean, we wouldn't want them to use it because we wouldn't want NTFS to think it owns a partition it really doesn't know anything about.
No one's ever going to own a partition that you don't want to. I mean, I don't know. I mean, if you have a disk today that has a partition on it that doesn't have one of those values, there's no way to get to it in DOS or OS2 today.
Right, but this is part of why we're here, is to put a file system in T that may be able to read some...
Yeah, just use 7. I mean, that means your installable file system and you're the only person that understands that particular type. HPFS and NTFS both use 7. There's a difference between a hardware partition on a disk and the on-disk structure in that partition, right? Both HPFS and NTFS use Type 7. Type 7 is the hardware partition for how that disk is actually physically partitioned. The file system that owns that partition is defined by who understands the structures on that disk. If you have your own file system on disk structure, NTFS is not going to recognize that, and HPFS is not going to recognize that. Only your file system driver is going to recognize that.
Okay, so it's not using the partition type to make any of those...
No one ever uses the partition type. The file systems don't know what the partition type is. In fact, the device drivers in NT don't even know what the partition type is. The only person that understands that the I/O system, and the I/O system's function IO read partition table builds an array of descriptors for where each of the partitions are that the device driver is supposed to create a device object for. It's the same thing that goes on in DOS. and OS2, except in this particular case, it's all bundled inside the I/O system, so the device drivers don't have to get it wrong. Does that answer your question?
Yeah.
Okay.
I have a question about the cache manager. I didn't really get a clear idea of what the cache replacement algorithm is that it uses.
You mean when pages are thrown out of the cache?
Yeah, which page gets thrown out?
Okay. Remember that there's a single virtual cache in NT, right? So these same pages, the same algorithm that's going to use for the cache manager is applying to other pages in the system. Okay, so Loop specifically has a particular algorithm that he uses, and I'm not completely fluent on what the algorithm is. Darryl might have a better idea of exactly the algorithm he's using to determine which pages go out when. There are standard working sets associated with processes as well. But to be specific about what the algorithm he uses, I'm not positive about that. But the idea to stress is that there's a single system-wide cache and that everybody's fighting for the pages.
Well, that makes it that much more important. Say you were just basically using it for reading. Is there any way you characterize that as an LRU replacement or least frequently used?
I don't. Yeah, Lou went through several iterations. There were iterations done through that. I'm not willing to commit to exactly what algorithm he's using. That's somewhat transparent to the issues that I was dealing with in terms of the optimization of memory management and dealing with working set replacements of pages.
Probably at this point we'll take this question, and I will send a piece of mail to Lou tonight and get an answer to it and tell you all about it tomorrow.
Yeah, I just don't want to make a false statement because I think Lou could give a very precise and accurate answer to that question.
My question is about removable media. Currently, if you eject an NTFS volume and throw another NTFS volume in, it seems to get confused. I'm wondering when this is going to be fixed.
Okay, I spent about a year getting floppies to work on FatWrite. So I'm totally serious. I had to rewrite a lot of the IO verify volume. There was a lot of iterations that went through this, getting the volume, all the volume tracking stuff to work right. When Darryl gave a little talk through of what happens when you put a floppy in, it was kind of an overview. There's a lot of detail going on there in terms of when we do mount after the verify, when we don't. We only do that if the verify fails. If the verify succeeded, we don't do another mount, for instance. There's things dealing with reference counts and VPBs that tell us whether or not we're allowed to tear down volumes. These have to be maintained by the file system if you're dealing with removable media. There's when files are opened on media that's been unmounted, the file system is required to keep track that is a file system that's not currently mounted. And then even when that volume has been mounted again, the file system must know that handle, that open handle, is on a volume that has gone through a verification. It has to do an analysis to determine whether or not that open handle still points to a valid file structure. Because understand that file that the open handle referenced may have been deleted. So part of the process of doing a verify after you put the media back in is to go through a handle when you get somebody uses a handle that was open before the verification process, that you go and make sure that in the best of your belief that file is still the integrity of that file hasn't been changed. So I'm sorry, I went off on a whole trade. What was your original question?
I'm wondering.
NTFS. When's NTFS going to work? It's one of our things we'd like to have work for the PowerPC release. It's on our plate of things to do to get real removable media. One of our device driver engineers, our lead device drivers, Botany, he always gets a kick out of NTFS supporting removable media, but you can't remove it. Because NTFS, when it mounts removable media, it locks the media in. And that was to avoid problems associated with ejecting it. Matter of fact, if you can eject an NTFS volume that you've mounted, then that means that your drive is not following the prevent media removal.
Well, in this case, it's in a jukebox, so the drive can't actually prevent removal. The robotics have their own.
So certain drives can, certain drives can't. I know that we just had somebody from Watermark Software up here, and they said, I believe it was the Hewlett-Packard drives did, and another version of drives didn't.
Okay, it's the Hewlett-Packard drive that I'm using.
And it allowed removal?
In the jukebox configuration, it allows removal.
Okay. Yeah, there were two.
Drive, it doesn't.
He was in his jukebox. He had noted that as well. That when he swapped drives, some prevented removal and some didn't. It just wasn't implemented on the drive. So.
Okay, we'll take one more question. The buses are here, and we're going to need to start moving in that direction before too long. We'll take one more question, and then Robert had a reprise on his talk. that should only take a minute or two, and then we'll call it a day.
Right. The question relates to the issue of locking down sections of your file system code which may have to deal with page faults. There are two parts. One part I gave you a bit of paper for, but it was basically how can you determine the range of addresses in your code which needs to be locked down to prevent faulting. And the other part was, if you posit the situation where you don't want to lock your code down unless you know that you're running a paging file on your file system, is there any way to know whether or not you are actually running a paging file at any particular time?
The answer to, I'm not sure what the answer to your second question is. I can answer your first question. David would like to add something when I'm finished. Basically, there are intrinsics in the compilers that we're using that allow you to specify what function or functions in each module go into the section that's going to be paged. Basically, what you then do is you give it the address of the function you want, and the compiler and the linker work together with the memory manager to figure out where that section actually resides, and we lock the thing down.
Doesn't that imply that you're going to be stuck with static determination of which code you lock down rather than being able to decide on the fly whether the code's going to be locked or not?
Yeah, yes, it does, and locking down your code is an extremely expensive operation. We would highly suggest that you don't go run around dynamically locking and unlocking pages.
By dynamically, I was thinking of the case that you may have a file system which, while it's capable of supporting a page file, probably isn't supporting a page file, so it doesn't need to have its code locked down unless you actually have a page file on that file system.
Yeah, to give you an idea here, the paths that are important are pretty small, okay? We can detect that it's a paging file read or write coming in, and in our FSD dispatch routine for read and write, we directly call a special routine, fat perform paging IO operation, right, for reads or writes. And that's the only thing that has to actually be resident, is a very small FSD dispatch entry point, and then a routine which is specially tailored just to do paging file. Remember I gave all these special rules, things that you don't have to do with paging IO? Well, because of that, this routine is really small. To give you an idea on FAT, the overall size of FAT is, what is it, like 100, do you remember the free size of FAT is? 100 something K, right? It's like a big thing, and it was only like 6K of it was resident. It was pretty small. I was able to get to, so hardly any FAT was resident. So it's really not much of an issue. The important thing is to make sure you know those code paths, the ones that are involved in running reads and writes actually are resident. But you can get it really efficient.
Even in a situation where it may be that the inherent nature of your file system is such that code you need to do the file system work at that level is still quite large.
You don't need much code though, right? Because the memory manager is giving you the range that you need. All you need to be able to do is do mapping lookup. And in our case, we have a library routine that we use to do that. And so all we need is just, given the virtual extents in the paging file that we're supposed to write, one virtual range, and we decide if that's a single run or several runs, and then we send them all down. And I mean, literally, that piece of code to do paging file I/O is maybe 50 lines total.
Actually, the API that allows you that the memory manager uses to get one of these things open, you can actually tell anyway. I think you can actually let the paging IO flag being set, and you can use that to determine whether or not you'd lock all that code down. So in that case, you wouldn't even have to have it locked down in the first place until someone actually opened a paging file on your phone, so you could actually do what you're trying to do.
Right. Assuming you knew the range of addresses, that goes back to the other part of the question, because you said you have to use the linker, the compiler directives to control the placement of code into fixed and non-fixed areas.
That just determines what goes in what section.
Right.
Right?
Okay.
The compiler works with a link. The compiler takes your code, and for each function, it says, here's the starting address, here's the ending address. Right? We then bundle all the guys that you said are paged and put those in one section, and all the guys that aren't paged and put them in another section. For the guys that are paged that you need to handle paging I/O, when you know that you're going to need that, i.e. in this particular case, you came in and
from the memory manager who's trying to create a paging file or open an existing paging file. He says this is going to be paging I/O on this particular file. You look at that bit and you go, oh, I'm going to need those pages. You lock that page, you lock that section down. The linker simply gets involved in the sense that what it does is it puts together all the functions that are supposed to be in that section into the same section and creates a descriptor for that then the memory manager uses to figure out where in virtual address space those pages actually are so that it can lock it down.
Great, that's the full answer, thanks.
We're going to have Robert do a reprise on his talk now, and then we're going to call it a day. The buses are here, and we're going to have to load up pretty quickly. So.
Very brief, someone came to me after my talk when I was standing in back and suggested I pass on the following word of wisdom, which is good words of wisdom, having spent 6 months gluing a security system into an object management system that didn't have it in the first place. And the suggestion is to make sure that if you are putting security into your file system, make sure that you plan ahead for it and design it in up front. Because a lot of time, what you may find, what I found, having not with NTFS was done correctly, but other parts of the system were not, is that you can find that you're going through some pretty torturous stuff to get the information that you need in the right place at the right time. So as you're sketching out the designs for your system, how it's all going to work, think about, I'm going to need to do an access validation here or an audit here. How do I know that I have everything I need to actually do that? And you can save yourself an awful lot of grief. And that's my piece.
Okay. Thank you all. We'll see you tomorrow morning.